Thank you so much for coming, and thank you so much for having me. The QCon audiences are always fantastic, thank you so much. So I'm going to be talking today about running third-party JavaScript safely. So code has power. There's this great quote from the Structure and Interpretation of Computer Programs, and it says, in effect, we conjure the spirits of the computer with our spells. So we conjure the spirits of the computer with our spells. And as programmers, we have tremendous power, right? And we can use this power for good, or we can use it for evil. So code can read our files, it can delete our files, it can send all of our data over the network, it can drain our bank account, and much more. So my name is Kate Sills, and I work for a startup called Agoric. And there's two things that you should probably know about Agoric. Number one is that we are building a smart contract framework that we hope can handle millions of dollars in digital assets. And number two, we're doing so in JavaScript, which probably sounds like a terrible idea, right? So I'll explain how we're able to do that. But first, can I see a show of hands? Who's primarily a JavaScript developer? Okay, so we got a lot of JavaScript developers. Who's primarily developing in something else? Python, Rust, anything? Okay. So at Agoric, like I was saying, we're at this intersection of cryptocurrencies and third-party JavaScript. We use a lot of JavaScript packages. And it turns out that this intersection is just a really A+ target for attackers. So what's going on here? So NPM has some great statistics. They say that there's over 1.3 billion downloads of NPM packages on an average Tuesday. So that's a lot of downloads. And JavaScript has this rich culture of code reuse, as we were saying earlier today in the panel. So here's some more stats from NPM. There's over 800,000 packages on NPM, making it the largest code repository in the world. And the average modern web application has over 1,000 dependencies. So NPM has this great quote. They say that over 97% of a modern web application comes from NPM, and an individual developer is responsible only for the final 3% that makes their application useful and unique. So we can think of all the time that's saved by not having to reinvent the wheel, right? That's hundreds of millions of hours of coding saved. And I think this is a really beautiful example of the kind of cooperation that humankind is capable of. We have this rich civilization of code, right? So we should be proud, and NPM should be proud of everything that they've accomplished. We have specialization. We have experts, right? We don't have to build everything ourselves. And as long as we can rely on all of these package developers to be good people, we're fine, right? But not everyone is good, and not everyone is good all the time. People make mistakes. And as Superhands from Peep Show once put it, people like Coldplay and voted for the Nazis, right? So, you know, what happens when things go bad? So using other people's code is risky. And it's risky because whatever package we install can basically do whatever it wants. So there are no restrictions, and we may not find out what happens until it's too late. So in real life, right, we have this rich ecosystem. We're able to buy and use the things that other people create. And we don't have to grow our own food or sew our own clothes. But imagine if everything that you bought, all the interactions that you had over the course of the day, that coffee that you bought this morning, imagine if that had the power to completely take over your life, right? That'd be ridiculous. It'd be absurd. But that's the situation that we're in right now with JavaScript packages. We can't safely interact with the things that other people have made without it potentially ruining us. So let's look at how authority works in Node.js. And I'm going to focus on Node.js for a bit here. But by authority, I mean the ability to do something, right? And so authority in Node comes in through the use of imports. So you can require certain modules. You can require the built-in modules. And it comes through the use of global variables. And it turns out that anyone or anything can import modules, especially the Node built-in modules, and they can use the global variables. And the effects of this use, it's often opaque to the user, right? So there's nothing that pops up and says, alert, alert, your files are being sent over the network. any of these usages could be in packages that are many levels deep. So that means that you may think you're installing something that's very simple, very safe, but actually it could be doing something very malicious behind the scenes. And Node provides no mechanisms to prevent this kind of access. So to illustrate this, let's imagine that we're building a web application, and we want to add a little excitement. So let's say that we install this package, add excitement, that just adds an exclamation point to the end of a string. So if this notation isn't familiar, this is just a template literal, and so we're literally just adding an exclamation point, right? So our hello turns into hello. So it turns out that add excitement could actually be written like this, and we wouldn't know any different, right? So from the user's perspective, the functionality is the same, right? We're still adding an exclamation point, but behind the scenes, we're getting access to the file system. So FS is the built-in Node module for accessing the file system. And we're also getting access to the network through HTTPS. So let's say an attacker could potentially say FS read file. Let's say that's my Bitcoin private key there, and they could essentially send this over the network. So this code is simplified a little bit, but I think you can see what's happening. So just through access to the Node built-in modules, any attacker, through the installation of pretty much any package, can read all of our data and send it over the network. So in the cryptocurrency world, where we're dealing with wallets that may hold private keys, that are holding digital assets, this is a big deal, right? So this is a problem. So let's go over to steps to read any file. So number one, we had to get the user or another package to install our package. Number two, we had to import the Node built-in module, FS, to get the file system. And number three, we had to know, or we can guess, and there's no penalty for guessing, the file path. And that's it. That's all we had to do, right? So this is actually a pattern of attacks. So you might have heard of the event stream incident that happened in 2018. And what happened was there was this open source package maintainer, Dominic Tarr, who had over 100 open source packages that he was responsible for. And so a volunteer came up to him and said, you know what, I'll take care of the event stream package. Let me take it off your hands. And so Dominic Tarr was like, okay, that sounds great, right? Someone's going to be doing the work that I've been doing. So this volunteer, they made some changes, but they also managed to insert a malicious package dependency in the event stream package. And this malicious package was specifically targeted for a specific cryptocurrency wallet. And what it tried to do was it tried to take the Bitcoin private keys, exfiltrate them, or send them over the network, and ultimately steal Bitcoin. So we saw this pattern again last year with the Electron native notify package. And again, this was trying to target cryptocurrency, and it was also using the file system in the network. But this one, it was caught by NPM, luckily. So that's great, but I think we're going to see this pattern repeat itself unless we're actually solving the root cause of this problem. So what are the solutions? Well, there's always the tried and true solution of just ignoring it, and then hopefully it'll be okay. But people are actually really trying to solve this problem, right? So one of the solutions that people have come up with is, just don't use open source, right? Write everything yourself. And believe it or not, there are companies that are actually doing this because the stakes are so high, right? But we can see that this isn't a very scalable solution, right? It's not very practical for all of us here. If I had to write everything myself, I wouldn't get very much done, right? And we would lose the millions of coding hours that we save by reusing other people's code. So I think this solution isn't very practical. So another solution that people have been proposing is to fund open source developers, right? So let's pay someone to maintain these packages, and if someone is paid to be responsible for them, then hopefully the security will be better. So I think this is good. We need to pay open source maintainers, we need to pay open source developers, but just because someone is responsible doesn't mean that they can't be compromised or they don't make mistakes, right? Okay, so lastly, another solution that people suggest is that we should audit open source code. And this is also a good suggestion, but code audits are not a panacea, right? They can't solve everything. There are things that code audits miss. So here's an example of the utility of code audits. Does anyone know what this code does? Any guesses? OK, so this is actually doing a window.fetch. So this is accessing the network. And how it's able to do this is that that first line, the const I, is fetch, just shifted over one character. And then the self in the third line, there is actually an alias for window. So you can see if we're just manually looking at code, we're trying to find code that's problematic, I would probably just skim over this and not notice at all that something problematic is happening. So this just goes to show that doing a manual review of code is very difficult. And even if we had infinite time to do a review, we might not find this. And we definitely don't have infinite time. So if we go back to the steps to read any file, we can see that a lot of the solutions, they focus on number one, right? They want us to be able to trust the open source maintainers. They want us to only install packages that we trust. And I think improving this is all admirable. I don't want to stop people from doing that. But I think what we should really be focusing on is number 2 and number 3. So what happens when the malicious code tries to import the file system and it just can't, right? What if it can't import FS? Or what if the malicious code knows the file name or knows the file path, and that doesn't help it at all, right? So there's this great quote from Alan Karp that goes towards this point. He says, the mistake isn't asking, how can we prevent attacks? When we really should be asking, how can we limit the damage that can be done when an attack succeeds? The former assumes infallibility. The latter recognizes that building systems is a human process. So what we actually need is code isolation. And it turns out through an accident of history that JavaScript is especially good at code isolation. So JavaScript has a clear separation between kind of the pure computation and access to the outside world. So it typically, the host, the browser, or node is the thing that provides access to the outside world, whereas TC39, or the JavaScript Standards Committee, has focused on the pure computation part. So through an accident of history, we have this clear separation. So if we sever that connection, we can actually get rid of a lot of the harmful effects. And this is not necessarily true of other languages. So as JavaScript developers, we're actually in a really good place to start with for code isolation. So as I mentioned earlier in the panel discussion, so JavaScript already has the concept of a realm. It's not very widely known, but the realm is in the spec. But basically what a realm is the environment in which code gets executed. So each web page is its own realm. And code that executes on one web page, right, can't necessarily affect the code that executes in another. And so within a realm, the realm starts off with all of the objects that you would need when the code starts running. So that includes things like object, function, array, and we call those primordials or intrinsics. So a realm also consists of a global object and a global scope. So historically, one way that people chose to isolate code was in the same origin iframe. But using an iframe is clunky, right? And we want to be able to create realms without the overhead of iframes. So that was the concept behind a TC39 standards proposal called realms. It was, what they were thinking was, why don't we actually create these realms without the overhead of an iframe, right? Without the DOM. And what if we could do it in a very lightweight and easy way? So creating a new realm creates a new set of these primordials. And a realm is almost a perfect sandbox, right? So whatever code is isolated in a realm is isolated from the rest of the world, and it can't cause any effects in the world outside itself. So malicious code that runs in a realm can do nearly no damage. OK, so like I said, this is a proposal before TC39. It's currently at stage 2, which is draft. So the fact that it's a proposal means that we're hoping to push it forward so that it actually gets into the JavaScript language itself. OK, but what if realms themselves are too heavy? Can we go even lighter than that? So rather than duplicating all of the primordials, the things like object, array, function, that sort of thing, a featherweight compartment just shares them, and this makes the compartment much lighter. So a newly created compartment doesn't have access to the outside world or any of the host-provided authority, so we can safely evaluate code in that compartment. So let me just show you how this works. Let's see. OK, so I'm going to take the code that we saw earlier. I'm going to execute it just here in the console. And if it succeeds, then we'll hit this URL, and yep, the attack was successful, right? So now I'm going to execute the same code, but I'm going to do it within a compartment. And I don't know if you can see at the bottom here, but it says cannot read property fetch of undefined. So window or self was not even defined within this compartment. So it had no access to the outside world, right? So this is great because we didn't even have to read this code. We didn't even have to understand what it was doing. And we were still protected. All right. OK, but we still have a problem. And that problem is known as prototype poisoning or prototype pollution. So this has kind of been a recent scourge. There's been, I think, at least 20 vulnerabilities that have been found in 2019, including ones in Lodash, Angular, and jQuery. And so what's happening with prototype poisoning or prototype pollution, there is an Angular example here on the slide. But what's happening there is that, let's say we get a string from a user, right? And then we try to JSON parse it. And then we try to merge it with an object that we already have. OK, so that seems fine, right? The problem is anything that has the double underscore, double underscore, will actually be adding a key to the object prototype, the prototypical object. And so all of the objects within our realm will have that key. So you can imagine a kind of attack where, let's say, some kind of mechanism is restricted to only objects that have like admin equals true or something like that, right? So an attacker could just put in, proto and then admin equals true, and then all of a sudden, they have access to everything, right? So you can imagine that kind of attack. Here's another example of prototype poisoning. So if we're able to modify array prototype map, then we can actually change it to do whatever we want. But we can retain the original functionality. So from the outside, it looks the same, right? But under the hood, it's actually sending all of the data in the array over the network. So not great, right? So to solve the problem of prototype poisoning or prototype pollution, what we can do is that we can use these compartments, but we're also going to use transitive freezing, or what we call hardening. And we want to try to freeze all of the primordials so that when someone tries to change the behavior of map, or when someone tries to change object, they just simply can't because it's frozen. OK, so SES, or secure ECMAScript, that does this kind of hardening, that does this kind of freezing, is pretty easy to use. All you have to do is do an npm install. And then this particular API is actually new of the last week or so. So things are really kind of rapidly in flux. But what you do is you import a lockdown function. And that lockdown function, once you call it, it freezes all of the primordials in the realm that you're already in. And then once you do that, you can create new compartments within that realm that will allow you to safely execute third-party code. Oh, and you might notice that we have to stringify the code right now. So we're still working on kind of the developer ergonomics issues. OK, so what if our code actually needs a lot of authority? Right? You might be saying, isolation is all, is all well and good, but my code needs access to the file system. My code needs access to the network, right? OK, so there's this thing called the principle of least authority, or POLA. It's also known as the principle of least privilege, but POLA doesn't sound as great. So what POLA means is that there should be no ambient authority and no excess authority. So by no ambient authority, we mean that by default, the code shouldn't have any authority. So you know how in your normal Node programming, you can import all of the Node built-in modules, you can install scripts, you can do all of that kind of stuff. We shouldn't be able to do that under POLA. Right? So authority should be explicitly granted by something external. It also means no excess authority. So only the bare minimum authority should be given. So don't give any authority more than is necessary. So let's look at an example. Let's do a simple command line to-do app. We're only going to be able to add and display tasks. We're not going to be able to delete them. And the tasks are just going to be saved to a file. Right? So it's going to be very, very simple. And we're going to use two packages. We're going to use Chalk and Minimist, both of which have over 35 million weekly downloads. And what Chalk does is that it adds color to the console logs. So you might be red, green, blue, whatever it is. And Minimist just parses the command line arguments for us. OK, so here's an example of it in use. Let's add a to-do to pay the bills. Let's add a to-do laundry. And then let's add pack for QCon, and let's set that to priority high. Right? So it'll show up in red. OK, so if we analyze the authority, things start getting really interesting. So first, the command line to-do app, it's going to need access to the file system, right? Because we're going to be reading and writing to a file. It's also going to use Minimist, like I said. But Minimist is pretty much a pure function, right? So it doesn't need to use a lot of authority. It's just going to be acting on the arguments that we give it. Chalk is very interesting because it uses a package called supports color. So this Chalk package that is really just about changing the color of the console logs, it's going to be using supports color, which in turn uses process, which is a Node built-in, it's a global variable, and OS, which is a built-in Node module. So if we have access to process, it gets very interesting because we can call process.kill, and all we need to know is just the process ID. We can kill any process. If we have access to OS, we can set the priority of any process, again, just by knowing the process ID. So this very simple Chalk module actually has the power to kill any process and set the priority of any process. So how can we use SES? How can we use secure ECMAScript to enforce POLA? So let's go over two patterns that we can use to minimize authority. The first is going to be attenuation. So we're going to want to attenuate our own access to the file system. And we're going to want to attenuate Chalk's access to process and OS. The second thing that we're going to go over is virtualization. So we can intercept the information that Chalk receives, and we can change it to whatever it is that we want. OK, so to attenuate our own access to FS, let's just write a simple function that will check the file path. And if it's not the file that we expect it to be, we're going to throw an error. Right? So pretty simple. And so to actually attenuate, we'll take the original FS object. We're going to throw away all of the methods that we don't actually want to use. Right? So we're just appending and reading from a file. So we actually only need the append file method and the create read stream method. And in each of these, you can see that we are calling the check file name method that we saw earlier, so that if it's not the exact file name that we expect, we're going to throw. OK? So let's also, let me go back a bit. So there might be a question of, why do you want to attenuate your own authority? Right? Don't you trust yourself? Right? But people make mistakes. People get compromised. Right? So it's actually part of the best practices for POLA to try to attenuate your own authority. OK, so Chalk's access to OS and process. So first, let's try to get rid of all of the ambient authority. So if we're executing this within a SES compartment, we've already solved that problem. We actually can't import OS and process, right? So actually, what we're going to want to do is to be able to pass in that authority instead in the form of arguments. So we rewrite Chalk so that it takes in OS and process. And we do the same thing to supports color as well. OK, so the reason why supports color needed OS was simply to get the string for the release. This is crazy, but actually, I guess there's, if I remember correctly, there was some kind of color blue that doesn't show up on a certain Windows system. And so it needed access to OS just to find out if it was that particular type of machine so that it would know how to change the color of blue so it would show up. So that incredible authority that we thought we needed, it actually doesn't need at all. So what we can do is take the original OS object and just pass along the release and not pass along anything else. OK, so that was attenuation. And then for virtualization, we're going to actually take the process global variable, and we're going to only pass along the things that are necessary. So you can see we're creating a new hardened or transitively frozen process that has mostly the same thing. But for a platform, we can actually put whatever we want there. So I'm using a Mac right now, but we could put Win32 if we want to, and we can effectively intercept the information that the chalk package gets. So when it comes to enforcing POLA and access control, it turns out that actually the best way to enforce POLA is to use something called object capabilities and to not use identity-based access control or access control lists. So this is very simplified, but typically in access control, right, you're mapping people or accounts to some sort of centralized permissions, right? So does Susan have the permission read location? Does David have the permission write to file? So very simplified, but I think you get where I'm going. And then performing an action, it does a lookup in this table to see if whoever was originally calling it has that permission. OK, so that's the typical case. But object capabilities, in object capabilities, there's no separation of designation from authority. So, and there's no centralized permissions. So we kind of saw object capabilities already in our attenuation patterns. But basically what you're doing is that you have the authority to do something if you have a reference to the object that has a method that allows you to actually do that. So your designation and authority are actually embedded in the same thing, in the same object, and all of the authority is in the methods themselves. So JavaScript has unforgeable references. So that means that we can't, if we don't have access to a specific object, there's no way that we can kind of fake our way or guess our way into getting there. We only have access to an object if someone grants us access to it. And it has a clear separation from the outside world, again. And so JavaScript is actually very well designed for object capabilities and the use of that pattern. And under object capabilities, it's very easy to reason about authority because the graph of which objects have references to which other objects is actually the graph of authority. So if you're interested in more on object capabilities, I really recommend Chip Morningstar's post at habitatchronicles.com. It's a great read. So let's go over SES as used today. So like I was saying, so Realms is at stage 2, SES is at stage 1 at TC39, but people have already started using it. So first, Moddable is a company that's doing JavaScript for the Internet of Things. So it's a little similar to the talk that Gordon gave this morning. And they have this JavaScript engine called XS that's specifically for embedded devices. And they've already built SES for XS. And they use SES to enable users to safely install apps using JavaScript on their IoT devices. So you can imagine, I think they have a Whirlpool washer. I think they have an oven. Light bulbs, other things like that that are all running JavaScript, which is pretty insane, but pretty cool. So they gave a demo recently where they allowed users to write scripts that would run on an LED light bulb. And what's really cool is that they were able to restrict the scripts so that, number one, the scripts had no access to any of the configuration settings. This has actually been a big problem in IoT devices, is that something that you're running could actually get access to your Wi-Fi password, something like that. The scripts also were limited in the maximum brightness, so it didn't blow out the LED light. And lastly, they restricted the frequency of change so that someone couldn't write a script that would trigger a seizure or anything like that. So another example is MetaMask's LavaMoat. So MetaMask is one of the main Ethereum wallets, and they're using SES to kind of pin down their supply chain. So they have a Browserify and Webpack plugin that puts every dependency that they use into its own SES compartment. And they're using a different approach than what I just went over. They're using kind of a backwards compatible approach. So they don't want to rewrite all of their different dependencies. Instead, what they're doing is that they're creating a manifest of the authority that's currently being used. And then that is the only authority that those packages get. So let's see if we can actually see this. OK, so they have a great visualization here. So here's all of the dependencies that they use. And on the left here is the kind of manifest that's created that shows the authority that's being used, like the global variables, things like that, and the other packages that are being imported. So my visualization's a bit slow here. So the green is supposed to be safer. The red is supposed to be more harmful. And so we can also see what it looks like without SES. All of them are red, right? Because we would have no idea what any of them are doing. They could all be doing things under the hood. So MetaMask, they're also using SES in a product that they call Snaps. So what was happening in MetaMask was that all of these different projects were asking for new features for their Ethereum wallet, right? So it was getting very political. You know, which features are we going to add next? How do we choose? That sort of thing. So what they decided was that let's just allow the users to write their own scripts, right? So let's create a platform, a plugin platform, so that we can actually allow custom behavior into MetaMask and do so safely. So this shows, along with the light bulb example, that SES is not just for securing JavaScript dependencies. It can also enable you to provide a plugin platform. And Salesforce, one of the primary co-authors of Realms, uses a version of Realms in production in their Locker Service plugin platform, which is an ecosystem of over 5 million developers. And of course, we're using it at Agoric in our smart contracts. So we use SES to allow users to upload their own smart contracts, what we call agreements enforced in code, and they can upload them to our testnet and safely interact with each other. So I want to be upfront about the limitations of SES. So it's still a work in progress. The API has been changing. Like I said, it changed recently in the past week or so. And we're still working on performance and developer ergonomics. So like I said earlier, you have to currently stringify the code that you want to execute in this secure environment. But Realms is at stage 2 in the TC39 proposal process, and SES is at stage 1. So in conclusion, SES provides nearly perfect code isolation. It's scalable, it's resilient, it doesn't depend on trust, and it enables object capability patterns like attenuation. And most importantly, SES allows us to safely interact with other people's code. So we can use your help. There's 2 repos here. One is the SES shim, so this will allow you to start using it. And then the other is for the SES proposal at TC39. And please, check it out, play around with it. Please find bugs, let us know. And I think that's it. Thank you so much, and I'd love to hear your questions.
Thank you very much, Kate. I'll go first. Since this actually goes back to some of the stuff we talked about in the JavaScript panel earlier today, which was because there are so many modules in the Node ecosystem, the thing for me that would be really awesome is if I'm importing a module at the top level, do these tools analyze everything all the way down the tree? So I can just say this thing and all of its dependencies only have access to this one method in OS or whatever. Does that work?
Yeah, so if you're only using the SES compartments and you're not using anything else, it won't do any analysis for you, but it will disallow any access to the outside world whatsoever. So you start off by default, with completely no access. So you start off from a very safe position. That doesn't give you a lot of efficiency or ability to use it. But the approach that MetaMask has been taking, where they kind of they try to look at the authority that each of these packages is requesting, and then they create a manifest that restricts the access to that specific authority, I think is a pretty solid approach. So the event stream incident that we saw, it was a sudden escalation of authority, right? That was unanticipated, and it went unnoticed for the most part. But if we had a manifest that we were using to restrict authority, that kind of escalation just wouldn't be possible. So I think it's still in the early stages. We're going to see patterns of use. We're going to see tools being built to help people try to decide what authority certain packages should get and that sort of a thing. I know in the panel we talked earlier about having the possibility of being able to look at what packages are using. Right? So maybe when we're searching through NPM, we're actually able to see what kind of authority is being requested, and we can decide whether or not to use a package based on that. So I think it's very early, it's kind of in its infancy, and we haven't necessarily seen all of the patterns of use that we're going to see in the future.
Okay, that's really cool. Does anybody have any comments or questions? Yes.
Yeah, have you considered going further and actually prevent imports before they actually take, like if they're not going to be safe or they are going to contain things that you're not going to authorize, just to prevent imports altogether so they don't build up on your code base?
Yeah, so just to repeat the question, it was, have you considered disallowing imports entirely? Is that basically it?
Based on authority and other...
Mm-hmm. Yeah. So by default, if you're executing code in a SES compartment, you can't import anything. And so I think, generally, that would be the approach that we recommend, is that anything that you do actually have to import, if you're writing everything yourself, if you're kind of starting from scratch and you really want it to be secure, pass those in terms of an argument. Just because the way that imports work, it's nice, it's easy to use, but it does have that kind of ambient authority problem where it's not clear that authority is being explicitly granted, right? But I think the tools that people are building, where even you may be able to import something, but the manifest that you have may determine that you say you're requesting something, but you actually get something else, kind of the virtualization pattern that we saw. So we'll have to see how those things evolve, but we have a good start on that.
Hello, you had an example on there whereby I think you were using the compartments in order to show that fetch was undefined, and that was kind of thrown back to the parent to say, oh yeah, we don't have that in scope. To your knowledge, there might not be, it's more of an open question. Is there anything at work that almost acts as middleware between that and the parent to say, by the way, this has tried to elevate privileges, and then you could almost log that to Sentry or something like that in order to say, by the way, this package has tried to do something that we didn't anticipate it doing. Is there anything like that going on? Or?
Yeah, so I think that's a fantastic idea. I haven't seen anyone build that specifically as a package, but it does match. There's a pattern in object capabilities known as the power box pattern. And my understanding is that it's very much like that. So there may be a module that keeps track of the kind of authority that's being used. And if other packages request authority, then it gets to decide whether or not they get it.
Power box.
Yeah.
And we have one back here.
When, so you talk about doing it in code and categorizing code, sort of JavaScript level?
So I think that's a really good question. I would advocate doing this at all levels. It just happens to be that the JavaScript level is where Agoric, the company that I work at, has been focused. So we've been part of the TC39's standards committee and have really been working at the JavaScript at the language level. But of course, you can try to limit authority at all of the different levels, and that's even a better solution.
So I have another question. From my perspective as a developer, this is really cool if you can get it to work, because I'm writing open source code and I want to release modules that people can use, and I want to feel secure in myself that I'm releasing secure code. But it strikes me that there has to be some tooling ultimately that lets me, from day zero, from today, analyze my existing dependencies, produce a manifest file. Now that's not perfect, because with dynamic code you can still have things that are not going to be discovered. And then move to a world where module writers are expected to produce manifests that say my module needs to be able to do X, Y, Z. Do you think we'll see that world?
Yeah, definitely. So there is a tool that's called TOFU, or Trusted on First Use, that Bradley Farias, who's kind of part of the Node security group, has been working on. And that tool does pretty much exactly what you were talking about. It takes a package, looks at the authority that's requested, and then kind of prints out a manifest that says, like, okay, so this is what the package says that it needs. If it's being nefarious, if it's being malicious, if it's requesting more authority dynamically, it just won't get that authority. So it takes kind of like the static analysis and creates this manifest, and then tries to use that to enforce the restriction of authority. So I think that's just one open source developer's tool, but I think as time goes on, we'll see that become kind of more professionalized and easier to use.
And you seem to be quite familiar with the standards process. Is there any movement at the standards level to define a manifest file format, or?
So I have not been part of the standards discussions. That's some of my other coworkers. So I'm hearing this secondhand. But there's definitely been movement. There's a proposal, I think, for module mapping. I'm probably getting that wrong. That seems quite tied to some of the manifest stuff that we've been talking about. So there's the possibility of using the module mapping to be able to kind of do that restriction of authority, especially to say, like, when they request this, actually give them this instead. But one thing that's been really exciting is TC53, which is the Embedded Devices Standard Committee. They have really embraced SES. So Moddable has been one of the companies that's been really big in TC53. So it may be the case that the embedded devices community gets SES before the rest of JavaScript.
Fantastic. Okay. Any further comments? I think that's a wrap. Thank you very much, Kate.
Thank you.